In section 10.2, we're continuing on with area, but now we're looking at area of trapezoids, rhombuses, and kites. So our objectives are directly related to that. Can find the area of a trapezoid. Then we're also going to look at using right triangles to find area, and then we're going to move into the area of kites and rhombuses as well. So the first thing we're going to look at is the area of a trapezoid, and we have our formula here. Area equals 1/2 your height times your bases added together. So instead of just base times height, I now have to take into account both bases, base 1 and base 2. All right, so looking at this first example, I need to know what is the area of the trapezoid with height 7 centimeters and bases, notice bases plural, 12 centimeters and 15 centimeters. So I'm going to plug into my formula. Area equals 1/2. Your height is 7 centimeters. And your bases are 12 centimeters and 15 centimeters. So you add those together. That gives you area equals 1/2 7 centimeters times 27 centimeters. So I use my calculator here. I'm doing 27 times 7 times 0.5, and I get the area equals 94.5. And remember, your units are always going to be squared. So that is your answer. And then I have a problem for you to try. It's very similar. This is a trapezoid. You just have to identify what your height is and what your two bases are. So here we're looking at the area of a trapezoid still, but we need to use trigonometry because they don't give us quite enough information. In this first example, you see that they give you your two bases, but they don't ever give you your height. So taking this picture, moving over, what we've done is we have inserted a height here. We need to determine what that height is by looking at this triangle that is formed and using trigonometry, or SOHCAHTOA. So my angle is 60. I'm going to draw my little person there. My angle is 60. I know that this side is 2 because it originally started at 7, and I dropped that line straight down, making this part 5, which leaves 2 left to be within that right triangle. So that would be my adjacent side. And I want to figure out my height, which is my opposite. So I need to use tangent. I need to calculate tangent of 60 degrees equals opposite, which is my height, over adjacent, which is 2. So to find h, I need to put into my calculator 2 tangent 60. So I'm putting that into my calculator right now. And I get h equals 3.5. I rounded, it was 3.46. I rounded to 3.5. So now I know my height. Now that I know my height and my two bases, I'm going to go back to this original picture. My height is 3.5. So my area is 1/2 times 3.5 meters times 5 meters plus 7 meters. So 1/2 of 3.5 meters times 12 meters. I put that into my calculator and I get an area of 21 square meters, or 21 meters squared. So that's my answer to this example problem. Now I need you to do that U-try, which is a word problem version of the same thing. So please go through that and bring that with you to class. Here we have the formula for finding the area of a rhombus or a kite. And it's actually the same formula. I have 1/2 diagonal 1 times diagonal 2. So in a rhombus, here are your diagonals. In a kite, here are your diagonals. You just multiply them together and then take half of that value. I have an example of each of those for you. The first example is finding the area of a rhombus. So again, I know my formula is area equals 1/2 diagonal 1 times diagonal 2. Well, my first diagonal, if this piece is 20, the whole thing must then be 40. And my second diagonal, if this piece is 30, then the whole thing must be 60 feet. And if I multiply that together, I get 120. Oopsies. I wrote it as a fraction, don't know why. When I multiply all of that together, I get 120 square feet is my area. Then you have a U-try problem there. I'm going to skip to the next example, which is an example with a kite. So I know that in a rhombus, I have these pieces of my diagonal being congruent because the diagonals bisect each other, but that's not the case in a kite. So a kite, you're going to have to think a little bit more carefully. If you look at this example over here, my 3's have been bisected, but this longer diagonal here is not bisected, so you have to be careful. Now, in the example that I'm doing, it specifically tells you what the two diagonals are. You don't have to calculate them. It says the first diagonal is 12 inches, the second diagonal is 9 inches. So all I have to do is plug that into my formula. I'm going to multiply 9 and 12 and then cut that in half. So I get my area is 54 inches squared. All right, and then there's your U-try. Please finish that up and bring that to class. And now the last thing we're going to look at is finding the area of a rhombus using Pythagorean theorem. So for a trapezoid, we have to use trigonometry when we're not given a specific value. Here, if you're not given enough information, you can use Pythagorean theorem within a rhombus. So looking at this first example, because I have a rhombus, I know that all of the sides are the same. So if this side is 5, then I know this side is also 5. Now the other thing that I know is if I drop a line straight down through this picture, that's going to be a perpendicular, and it is the perpendicular bisector of this diagonal. So if that whole diagonal was 6, I now have this piece here being 3 meters. Now I can use Pythagorean theorem because I have this triangle right here. I have 3, an unknown side, and 5. So I'm going to set up Pythagorean theorem. I have 3 squared plus my unknown side squared equals 5 squared. So 9 plus x squared equals 25. Subtract my 9. X squared is 16. If I take the square root of both sides, I know that my unknown side is 4. So I'm going to put that back in there. I now know that that is 4 meters. So let's go back to our original picture. If we need to find the area of a rhombus, I need the lengths of both of my diagonals. This diagonal they told me was 6. I had to use Pythagorean theorem to find this piece here because now I know that my entire length here is 8 meters. So I now know both of my diagonals. All I need to do is plug into my formula. 1/2 diagonal 1 times diagonal 2. So I get 1/2. My first diagonal was 6 meters. My second diagonal was 8 meters, which gives me 24 square meters is my area. And then I have a U-try problem for you to do. It's very, very similar to that. So please do that. Bring it with you to class, and I will see you then.